Hi guys, we're looking at more equations that have absolute values in them. We'll look at some today that are a little bit more complicated. So first, a quick review. Remember that we deal with an absolute value in an equation by writing the two possible ways that it can be true. So this will produce two equations, neither of which has absolute value bars, and we solve each equation, and thus we will have two solutions. So a quick example of that, like the ones we did the other day, we have this absolute value. In this case, it's n minus 4 inside the bars. We say that absolute value equals 4. Well, that means that either the thing inside, n minus 4, equals 4, or that thing inside could be negative 4. Either of those will make it true, and those are the only ways that that equation can be true. So we write them both down with the word or, and there's no absolute value bars, notice, in either one of them. That's good. And so we solve for n. And for the first one, add 4 to both sides, n equals 8. The second one, when we add 4 to both sides, we get n equals 0. So here we see we can check those answers. In blue is the number we plugged in for the variable. In the first case, we're checking the solution n equals 8. Plug it in for n. We get absolute value of 8 minus 4. That is the absolute value of 4. And then the absolute value of 4 is 4. So 4 equals 4, and it checks. The other possible answer we got, the other solution I should say, is 0. We plug that in for n. We get the absolute value of 0 minus 4 on the left. That simplifies to just the absolute value of negative 4, and that is 4. So we get the equation 4 equals 4, which is correct. So it checks. Okay, so what we want to do now is look at some that are more complicated. We see here that the absolute value expression is by itself on its side of the equation in all the problems we've done so far, such as the one that we just looked at. There's nothing else with the absolute value on the left. It's just the absolute value. And in fact, this technique that we've been using depends on that being the case. So what if it's not? What if there's something else with that? So we will look at some of those. And for example, example 2a. Okay, we have absolute value of negative 4 plus a, but that is minus 9, and that equals 0. So this time we have absolute value on the left, but that's not all that we have. See, I've written this down wrong. That should be a. Okay, so we have negative 9 with it on the left side, right? And we need to get rid of that negative 9, so we add 9 to both sides. Okay, that does get rid of it and leaves just the absolute value, negative 4 plus a. Equals 9. Okay, so we write our two possibilities, negative 4 plus a. It's not writing a's very well. Equals 9, or negative 4 plus a could be negative 9. Either of those make our original equation true. So solve them each. Solve both of those equations. First one, we're going to add 4 to both sides. we get a equals 13. And then the other one we add 4 to both sides, we get a equals negative 5. So those are two solutions. We'll plug those in. And check them real quick. So we write our equation, but everywhere there's an A, we plug in one of our solutions. We will first check A equals 13. So I'll write that in another color, blue, just to make it stand out a little bit more. So I plug that in for A because we're stating that we believe that is a solution. So now we're going to make sure. Okay, so the rest of the equation goes like that. Minus 9 equals 0. Go ahead and do this arithmetic. Negative 4 plus 13 is 9. That's inside the absolute value bar. And is this correct? Absolute value of 9 is 9. And we can evaluate 9 minus 9, 0, and it checks. Okay, so we'll go ahead and check the other one. For this one, we have negative 4 plus A, and this time we're going to check the solution. A is negative 5, so put that in for A. Make it another color. And then subtract 9 from that, because that's the way our original equation was. And we'll see if this works. So negative 4 plus negative 5 is negative 9. That's inside the absolute value. And we're saying we subtract 9 from that and we get 0. Well, you're seeing this is looking pretty good. Absolute value of negative 9 is 9. And of course 9 minus 9 is 0, so it checks. Okay. Let's look at a couple more. First, something like this. You have 10 times the absolute value, negative 6a plus 9, and that equals 90. The first thing I want to stress here is don't distribute. These absolute value bars are not parentheses. They're not just a grouping symbol. It's actually a function that's going to be applied to the result of that expression, negative 6a plus 9. Then you're going to apply the absolute value function, which we know how that works, right? If it's positive, then it just returns the same number. But if that evaluates to negative inside there, then the result of the absolute value will be its positive. It will be the opposite of that negative number, which is positive. So it's a function. It's applied to what's inside, and we can't distribute the 10 times that. There's no way to pull those numbers apart and do that. So what we do is we need to get rid of the 10, right? So just as we got rid of negative 9 up here, this 10 is something extra other than just the absolute value function on the left, so we need to get rid of it because we need to isolate the absolute value. So we divide both sides by 10. And so on the left, that gives us our negative 6. I'm sorry, it gives us, of course, the absolute value of negative 6a plus 9. The 10's, of course, cancel. And on the right, we get 9. Now we can deal with this the way we did them the other day because the absolute value is isolated. You can't do that technique unless it is. So we have our two possibilities. Negative 6a plus 9 could be 9, or negative 6a plus 9 could be negative 9. We solve both of those. We get negative 6a equals 0 for the first one. Dividing both sides by negative 6, that is going to come out to a equals 0. Okay, so we're solving the other one. Subtract 9 from both sides, you get negative 6a equals negative 18. So this time we divide both sides by negative 6, right? And we get a equals, and it works out okay. It's positive 3. Okay. Of course, we have the word or in there. Those are the solutions. Okay. So we'll look at one more. I will just kind of illustrate how to check this. Just want to emphasize what's going on here. We'll plug the 0 in for a first in this original equation, and there it is, 6 times a, but that's 6 times 0. We plugged in the 0 for a. Okay, plus 9 equals 90. And if you carry that on down, you will get, of course, absolute value here is 9. I'm sorry, what's inside the absolute value bars is 9. Well, the absolute value of that is 9. And so you get 10 times 9 equals 90. And 90 equals 90. So the other one was 3. 10 times the absolute value of negative 6 times that solution, which was 3, which will make blue. Okay, and that's plus 9 inside the absolute value bars. We're saying that equals 90. Well, what do we have in there? Might as well go ahead. Negative 6 times 3 is negative 18, plus 9 is negative 9. So you got 10 times negative 9. I'm sorry, 10 times the absolute value of negative 9. So that, of course, is 10 times 9, right? Because absolute value of negative 9 is 9. We are asserting that should equal 90, and when we multiply that out, we see that it does. Okay, so both of these solutions check. Let's do one more problem. And this one is just a little bit more complicated. Oh, I forgot to make this bigger. Sorry, just take a second here. Okay, we'll start that at the top. Okay. So now we have room to write another problem. Okay, which is C. Which looks like this. Okay. Okay, so you might notice, well, this has more to get rid of, right? We have 4 plus 7 times absolute value of negative 4 minus 3n. Those are all in the bars, equals 81. So again, you can't distribute this, so you need to get it by itself. So we'll subtract 4 from both sides first, and then we're going to have to, oh, made a mistake there, have to actually subtract 4 from that side as well. Okay, subtracted 4 from both sides. Now I divide both sides by 7. Okay, all we did, we want to get rid of that 7, so we divided both sides by 7. Okay, and that's going to cancel. That leaves negative 4 minus 3n equals 77 divided by 7 is 11. And now we've got it where we want. Of course, I can't get rid of my absolute value bars, so they're still there. Now, though, we are ready to say the thing inside, negative 4n minus 3n in this case, is 11, or could be negative 11 to make that true. So now we just solve both of these. Add 4 to both sides. Negative 3n equals 15. Divide both sides by negative 3, and you get n equals negative 5. Okay, the other one, we add 4 to both sides, and we get negative 3n equals negative, add 4, so it's 7, right? Negative 7, sorry. Okay, negative 3n equals negative 7. And so now we divide both sides by 3. N equals, and comes out to 7/3. So those are our solutions. And we won't check these, just reminding you, yes, to check it, you plug in for the variable in the original equation. You plug in negative 5 for n to check it. You plug in 7/3 for n to check that solution. Okay, so that's it. The homework is posted on Canvas. Just remember, you've got to have the absolute value sign by itself, and once you get that, then you will do them like we did the other day. You split it into the two cases, the two possibilities, I should say, and you solve each. You'll always have 2 solutions.